Circle C has center A with coordinates 7, 5. So I'm just going to write that on there. And then L is a tangent. It's got equation y equals 2x plus 1, shown in figure 3. And we're asked to show that the equation of the line PA is 2y plus x equals 17. So actually, this line PA is the normal at P. Not quite drawn it as good as I'd wanted. There we go. And the circle theorem is that the radius and the tangent are at right angles. Okay, that's how I know it's the normal. So because the gradient of the tangent is 2, then I can immediately say for the normal that the gradient is going to be minus a half. This is the negative reciprocal. We've got the x equals 7 and y equals 5. We've got the coordinate that it goes through. And therefore, we can either use y equals mx plus c, or y minus y1 is mx minus x1. Okay, this one's nice because we can just sub in. Y minus 5 is minus a half x minus 7. I'm going to multiply through by minus 2 or divide through by minus a half, however you want to see it. So that is going to give minus 2y plus 10 is x minus 7. And therefore 2y plus x, I'm adding 2y onto both sides, minus 10 from both sides equal to 17. So I've added the 7 onto both sides as well. And that is what we're asked to obtain. Find an equation for the circle. Well, we have the center, so we're already well on our way. X minus 7 squared plus y minus 5 squared is equal to r squared, but we don't have r at the moment. We need to calculate this distance here, but we don't know what coordinate p is. Okay, well, we can find that by solving these simultaneous equations, where the tangent meets this normal. Probably the easiest thing to do is just do a substitution in. Replace this y by 2x plus 1. So 2x plus 1 plus x is 17. That means 4x plus 2 plus x is 17. 5x is going to be 15. X is 3. Sub in to get y is equal to 7. 3, 7. Another way you could do it would be to write it as y minus 2x equals 1 and 2y plus x equals 17. And either use elimination, we could times the top equation by 2 and minus the equations, or times the bottom equation by 2 and add the equations, or use, so many different ways, use the simultaneous equation solver on your calculator. So I'll so x is minus 2x plus 1y is 1, and then 2y plus x, so 1x plus 2y is 17. And we again get x is 3, y is 7. Okay, that's just a little check as well if you want. Now we can apply Pythagoras' theorem to get the radius. It's going to be the difference between the x values, 4, we square it, the difference in the y values, 2, and we square it, and we square root. Because I could draw, I haven't really got enough space here, but I've got a little triangle here. 3, 7, 7, 5. So I'm actually going along 4 and down 2. That's where this comes from. It's a right angle triangle with shorter lengths 2 and 4. So 2 squared plus 4 squared. Square rooted, that's going to be root 20, which means r squared is going to be 20. And we've got our equation. Told that the line with equation y equals 2x plus k is also a tangent to C. Find the value of the constant k. What this means is actually we've got, so this had gradient 2, and so we can just imagine sliding this line down. It's got the same, it's going to be parallel, and it's going to be there. Okay, we can see where it's going to hit the circle. And there's two ways to do this. There's a nice quick way, and there's a slightly more involved way. using the discriminant. So I'm going to talk about the quick way, of course, first, and it is going to be the best way, especially for 3 marks. So we've got to kind of understand that we're going along and down to get to the center, and we'd be going along and down by exactly the same amount to get to the point where the other tangent hits the circle. And I've already seen that I'm going down by 2 and along 4 to get from 3, 7 to 7, 3. And so to get to this point here, I'm going to be going um, down by 2 again. So that's going to get me a y coordinate of 3 because I'm going 7 to 5 and then to 3. And I'm going along by 4. So 3 to 7 is along 4. Along another 4 is going to get me 11. So we've worked out using, our understanding of the fact that these are parallel. And basically the vector is going to be the same. So PA to AX is going to be the same vector. I'm just going along 4 down 2. And now I've got that, I can say y equals 2x plus k and sub in my 11 and my 3. So 3 is going to be 2 times 11, 22, plus k. K is minus 19. Could do y minus y1 again, but I don't know, it just felt a bit more natural to do this here. So that's going to mean, what did that, oh, actually, that's all it says to find the value of k. So very, very quick if you can realize that. Final answer, although we're not asked for it, would be y equals 2x minus 19. Second method, this one is more involved, but actually it's more general because that method worked because we already had a tangent. So what we can do is actually take our circle. By the way, this is going to be, it's going to take a fair bit longer. So I'm saying like you should go with that one in this case, but it's also worth just carrying on watching for other questions that might ask for, they might just give you a single tangent, y equals 2x plus k, and ask you what k is, and then we can still get it. So we've got our equation of our circle, and we've got the equation of our tangent, ignoring the other one now. So we can sub this in, we can try and solve simultaneously. Okay, replace y by 2x plus k. So I'm going to expand the x squared. I'm going to get x squared minus 14x plus 49. And then, hey, I'm going to get 2x. I'm not expanding it quite yet. 2x plus k minus 5 all squared. And that is going to equal 20. I'm going to treat the k minus 5 as like a single kind of constant moment. That'll make it easier to expand it. So I'm going to get 4x squared. Remember, this is a double bracket. Plus 2x times k minus 5, and then another one. So actually, it's going to be 4k minus 5x plus k minus 5 squared. And that's going to equal 20. I just want to very quickly say where we're headed with this, because this looks really complicated. But because it's a tangent, it's all about it being a tangent. It just glances off of the circle in one place. It's going to be one solution. The discriminant is going to be equal to 0. Okay, that is what this method is talking like where we're headed. All right. So what we can do, actually, I'm going to leave it. I'm not going to expand those. All right, let's simplify this. I've got x squared and 4x squared, which gives me 5x squared. Got minus 14x, and then plus 4kx minus 20x. Then it's plus 49, but I can minus 20 from that, so plus 29. And then I am going to expand this k minus 5 all squared, because then I've got another constant. K squared minus 10k plus 25. So 5x squared plus 4k minus 34. So you have to combine it all together into a single. There's our a, there's our b, single term for x, plus k squared minus 10k plus 54. That is actually my value for c. So 4k minus 34 squared minus 4 times 5 times k squared minus 10k plus 54 is equal to 0. We're not far off. Multiplying this out gives 16k squared minus, we're going to get 4k times 34 or minus 34 and then double it. And we've got 34 squared in there as well. Let me deal with this one first. 4 times 34 times 2 is going to be, sorry, putting that on the screen, minus 272. Okay. And then plus 34 squared, 1156. Minus 20k squared. 20 times 10 is 200, so plus 200k. 10 times 54 is 540, double that, 1080. (1156) minus 1080 gives 76. Okay, it's got to be said at this point you should put it in your calculator, but I'm going to carry on without. This is going to be divisible by 4. We can actually factorize it by hand. K plus 1. No, k plus 19 and k minus 1 will work. So k is 1 or minus 19. This is the one that we already dealt with right at the start of the question, so that is our final answer. Okay, very, very involved, but worth being aware of for harder questions. Definitely in this case, go with this method. Thanks for watching on to the end though, and well done.